All right, today's lesson is 1.06 Model Pythagorean Theorem. So really you just need your math notebook and a pen or pencil. You won't need your calculator today because we'll just be looking at the model, which looks like this. All right, we'll go ahead and get started. Our essential question is, how do I use the Pythagorean theorem to identify right triangles? I will be able to use the Pythagorean theorem to identify right triangles so that I can use the model for Pythagorean theorem. I'll know I got it if I can analyze a given model to prove the Pythagorean theorem. So words that you should know already. What a right triangle is. It's any triangle that has a 90-degree angle. And the hypotenuse is always the longest side of the triangle, and it's always opposite the right angle. So here's your hypotenuse, here's the right angle across, and again, it's always the longest side of the triangle. And the other two sides are called legs. So if you're looking at these triangles, the first one here says spot the hypotenuse. It's going to be across from it, so this side right here. Number two, our blue one, across, it's going to be this side. And three, across here, right here. It is important that you know how to find that hypotenuse. Just look for that right angle, go across. That's it. So here's the model for Pythagorean theorem. First of all, here is Pythagorean theorem. It states that if we square the length of the legs, it's a squared, this length is squared, and we square the length of the other leg, b squared, add those together and they will equal what c squared is. Works every time. So this is a visual, it's a model to show you that if this side was like 3, then this area would be 9. And if this side was 4, then this would be 16. And then this would be 5. That's 25. So again, the numbers I just put in there just to show you mathematically was the 4. Oh, my tablet's not wanting to work very good today. That's not good. All right, so 4 squared plus the 3. Oh, I did that backwards. This is the 3. Sorry, my tablet not working. Got me a little comboggled here. So this is the 3. Oh dear. 4 squared and would equal 5 squared. Terrible. So that's 9 plus the 16 will equal 25. So that just shows you the model and then mathematically how it works. So here's the numbers I just showed you, and you can see like if this side is 3, you square it, that gives you the area of that square. So there's 9 of these. This side is 4, that length. You square it, and there's 16 squares. And then this is 25. So there's another visual of it. But this side would be, the length is 5, and you square it, and there's 25 squares. So here is the theorem. It is on your reference chart. A squared plus b squared is equal to c squared, Pythagorean theorem for right triangles. So let's try a couple of practice problems. Says the diagram shows 3 squares that are joined at vertices to form a right triangle. Okay, so they're talking about this square, and this square. And here's our right triangle. Which statement is true? A, the sum of the areas of square N and square L is equal to the area of square K. That's what we just talked about. Square N plus square L is equal to square K. So It is A. We look at the other answers. It says the sum of the areas of square N and the square L is greater. Nope, it's equal. And C, the sum of the areas of square N and K is equal. No, not the K, and these two is equal to this one. And D, the sum of the areas of square N and square A or K is less. Not true. All right, one more practice problem, last one. This was actually a star question, so was the previous one. An artist joined 3 squares regions at their vertices to create the figure shown in the diagram. Same type of problem. We have region X, Y, Z. Now notice where your right angle is. So this one is your longest side. It's your hypotenuse. So remember from our theorem, modeling it, this region squared plus this region squared is going to be equal to this one. It says the artist will use small congruent square tiles to cover each region without any gaps or overlaps. Based on the information, which statement is true? A, the number of tiles needed to cover region X is the same as the number of tiles needed to cover both Y and Z. No, it's going to be the X and the Y added together will equal Z. So it's not A. B, the number of tiles needed to cover region Y, this one, is the same as the number of tiles needed to cover both X and Z. Nope. All right, C, the number of tiles needed to cover Z is the same as the number of tiles needed to cover both X and Y. That's the right one. So the answer is C. So please make sure that you complete your OMS lessons, work through those, take your time, read everything carefully, take notes, work out problems.